Hello all, this is 3.3 linear functions. I went ahead and said that this is a very cheesy lesson. I said that very intentionally. This is what you'll be doing tomorrow in class. And by the way, if I ever circle something on your notes in blue, that means it should be in your journal. I will also try to make sure I'm clear about what in the lesson during the video should be in your journal. I will also attempt to make this video shorter than the first one, so bear with me as I get better at making these lessons. Alright, so we're going to be talking about linear and nonlinear functions today. So our objective is to figure out whether something is linear or nonlinear based on tables, graphs, and equations. How do we identify them? So just to go ahead and review, remember a function is a rule in which every input has exactly one output. Linear functions are functions that have a constant rate of change that result in a straight line when graphed. The way that I remember that is that line is actually in the word. So you might hear me say something like line R in order to remind you of that. And nonlinear functions are functions that do not have a constant rate of change and does not make a straight line. So a straight line just being something without any bumps or anything in it. So like a parabola would not be linear. Alrighty, so let's take a look at these. I have a cheese under the correct answer. So which of these is linear? And we can see that the only straight line is this one, because this one's got a little curve going. This one has also a curve. This is like an absolute value graph, which we'll do later. So the correct answer has to be the straight line because it's a linear, and it is indeed that one. So for this one, we are looking for a non-linear function. So this one is a straight line, so that's linear. That one's a straight line, so that's linear. This one, even though it's a horizontal line, it's still a straight line, so therefore it's linear. And we can see that it is also not a straight line, it's two straight lines, and it has the cheese, therefore it is indeed correct. Another way we might have to look at something to determine whether it's a function is to look at a model. So here we have a model representing several different amounts of cheese. This one we've got 2 blocks of cheese on the first stack of cheese. So I'm going to put a 2 there. And the second one we have 1, 2, 3, 4. Notice that whatever stack of cheese we're talking about is our X. And the number of cheeses is our Y. And so for the third one, we have 1, 2, 3, 4, 5, 6 cheeses. The fourth one is 8. And we see that we don't have any repeats in our X. So that's a good sign that we are dealing with a function. What goes with the 5? And in case you didn't see the pattern, we've got 2, 4, 6, 8, 10. Would be the correct answer there. Hopefully you remember that rate of change is the same as slope, just to remind you. But look, for every X, I'm going up 1. So that's a constant rate of change. For every Y, I'm going up 2. So that is also a constant rate of change, meaning that every time I go up 1 in the X, I'll go up 2 in the Y. So the rate of change is constant, thus it is linear. Now let's take a look at this one. If I went ahead and plotted these points, well, first of all, I got to figure out what goes into my Y portion of my table. So I have 2 in the first one, and I have 4 in the second, and I have 3 in the third one, and in the fourth one I have 6. Okay, so now if I wanted to predict what I have in the fifth one, I would take a look at what pattern I see. So I see that from here to here I'm adding 2, from here to here I'm subtracting 1, from this to this I'm adding 3. So, another pattern I see is that I'm doubling 2, and I'm doubling 3, And it looks like I'm going consecutively. So 2 and then 3 and then maybe 5 will be 4 and 6 would be 12. So that seems to be the pattern that we're seeing. I mean, it could be a different pattern, but that appears to be what the pattern is. So let's ask ourselves if it's linear. So the way we would look at that is either graphing the points, or we can say, all right, well, the rate of change from these is all 1 again. But here I've got 2, 4, 3, 6, and then whatever 5 is, and we're going to go ahead and estimate that it's 4. So here you're adding 2, here you're subtracting 1, or here you're doubling, and here you're subtracting 1, and here you're doubling, or these are all going consecutively. Either way, the rate of change is not constant, therefore it is not linear. You'll also have to figure out if it's linear from an equation. Well, a linear equation is that form you guys all hopefully remember, y equals mx plus b. Well, what's special about that is that there's only one x, which is important because x squared is a parabola, so it's not a function. The absolute value of x you have not likely graphed yet, but it would look like something like that, which is also not linear. And this one is also not linear. That would look something like this. Oh, sorry, that would look something like that. And we will get to that another day. So therefore, the linear equation is the only one that actually fits what we know of as a lines equation, which is this one because of the single x. And we'll check it to see if we are right by dragging the cheese into the mouse hand. It'll highlight the correct answer, and we are correct. For your first example, go ahead and try to figure out which of these equations is linear. And here should be your second example. Which one of these is non-linear? So this is called standard form, and that is the standard form to write the equation of a line. So the standard form of a linear equation is like so. ax plus by equals c, where a, b, and c are constants. And the x and y represent the same x and y as y equals mx plus b, which is just an ordered pair. So with that in mind, let's take a look at this example. Alright, so first of all, ignore this graph. It is not the graph of this equation. So I'm actually going to scroll down over here to show you this example. So graphing in standard form is actually a really easy thing to do. It just looks difficult. So my equation is 3x minus 4y equals 6, and I'm going to need to graph this at some point. So the way that we graph this is by finding two special points, the x-intercept and the y-intercept. So if I take a look at my axes, my y-axis is right here. It's the vertical line, right? Which we know. So we also know that if we had some line here like this, the y-intercept is right there, where the y-axis and the line that we're talking about meet. What's special about that is that it also intersects the x-axis, the y-axis rather, intersects the x-axis at the origin, which means that any point that exists on the y-axis is at a point at which x is 0. So the y-intercepts all exist at x equals 0. Therefore, if I go over here, I know that my y-intercept will be wherever x equals 0. So I'm going to go ahead and plug x equals 0 into my equation to find my x-intercept. So I've got my equation here. So I'm going to go ahead and say 3 times 0, because that's what I'm plugging in, minus 4y equals 6. So now all I have to do is solve for y, which I'll find out is going to be negative 3 over 2, which is just negative 1.5. So my y-intercept is going to be at negative 1.5. Okay? So for my x-intercept, similarly to the y-intercept, the axes still intersect at the origin, which means that any line that crosses the x-axis will cross at a point in which y equals 0. Which means to find the x-intercept, all I have to do is solve for y equals 0. So I'll have 3x minus 4 times 0 by plugging into the equation, and that'll equal 6. So I have 3x equals 6, which just means that x equals 2. So x equals 2 is my x-intercept. And now all I have to do is connect those points, and I have the line of my equation. So to summarize, we have this, which is the steps I just took. I will let you read it on your own, but something you should definitely have in your journal is that your x-intercept exists at y equals 0, and your y-intercept exists at x equals 0. Another way to think of it is right here, and I actually like the way they word this here and here, specifically because of the way that they wrote their point here. So the x-intercept exists at x, whatever your x value is, comma 0, and your y-intercept exists at 0, comma, whatever your y value is. So go ahead and try these two for your next examples. For your next two examples, choose one of the next few slides that I will let go now, and go ahead and solve for the x and y-intercept and graph it. Just choose two of any of these examples that you see. And choosing any two of them and graphing them would be fine as long as you are doing two of them. And for our next example, you can't really see it here, but you're going to try to convert this into standard form. So you see right now it's in y equals mx plus b form, so I'm going to convert it into standard form, which again is ax plus by equals c. So I have y equals 1/2 x minus 3. I'm going to go ahead and use the exact same techniques that I used last chapter when I was solving for a variable, because our variable that we're solving for is getting a constant on one side for our c, and getting our x and y on the other side. So all I'm going to do is subtract 1/2 x here, and do the same over here. And x and y are not like terms, therefore my final answer would be negative 1/2 x plus y equals negative 3. Technically for standard form this is supposed to be in whole numbers only. If that is how you prefer to see it, which is how I would prefer to see it, I would need to go ahead and get rid of this fraction. So the way I would do that is by multiplying everything by the common denominator. The common denominator in this case is just going to be 2 because that's the only fraction. So I need to multiply everything by 2, which means I'm going to have 2 times negative half is negative 1x plus 2y equals negative 6. So hopefully that made sense. Alrighty, so for the next few examples, I'd like you to try them on your own. I will rewrite them so you can make sure to read them. I realize I got slightly cut off. So go ahead and try that one on your own. And go ahead and try this one on your own as well. That says y equals 7/2 x plus 1/4. And graph these final two examples, and that is the end of your 3.3 flipped lesson. Please turn it into eBackpack, and have a great night. Only leaves us with